Ahoy, mateys. We're jumping into solving absolute value equations. So it's basically like solving equations, but you got to do it twice. And we'll explain why in a second. So the core vocab is absolute value equation. That's any equation that has the absolute value symbols in it. Extraneous solution is similar to having like no solution when you're solving linear equations. And we'll talk about that. So an extraneous solution basically means it doesn't make sense. And then previous vocab is absolute value. So you have to know these lines are absolute value signs. And you have to know opposite. So if you have a positive, the opposite of that is a negative. And you have to use that principle every time you solve an absolute value equation. So first, let me just throw out a little question for you. I wish I had nice paper to write on. I don't. If I say that the absolute value of a number is 8, what could that number be? So there's two possible answers. It could be -8, because the absolute value of -8 is 8, or it could be 8. The absolute value of 8 is 8. So anytime you're solving absolute value equations, there's a potential to have two different answers, a positive version and a negative version. So here's some core things to know. These are all fancy. You can take notes if you want. I'm just going to talk about them briefly. I'm going to speed it up. I want to keep the video shorter. So what this is saying is the absolute value of any variable has to be bigger than or equal to 0. You can never have an absolute value that's negative. That's one property. Second property is the absolute value of a negative number is the same as the absolute value of the positive version of that number. It's like the absolute value of -5 is the same as the absolute value of 5. The third one is the absolute value of two numbers multiplied together is equivalent to the absolute value of each one of them multiplied together. So whether you multiply them together first and then figure out what the absolute value is, or do them separately, it's the same answer. And it's also true for division. If you're dividing two numbers, you can do them all together and then do the absolute value, or you can do the absolute value of each. But the second number can't be 0 because you can never divide by 0. So that's the properties of absolute values. Again, you can take notes. To me, as long as you understand it, because taking notes on this, it looks all complex and weird. So as long as you understand it, that's the important part. Now, here's the trickier thing. When you're solving absolute values of a complex linear or a more complex linear equation, there's going to be two possible answers where C is going to be bigger than or equal to 0. A positive version of that or a negative version of that. So anytime you solve absolute values, you'll be solving two different equations. Keep in mind, you're then going to check your answers to look for what are called extraneous solutions. Those are ones where this ends up being negative because we know absolute values can never be negative. And we'll jump right into it now. I'm just jumping right into it now. So here we go. Go ahead. Let's solve the absolute value of x minus 4 equals 6. If this is true, if the absolute value of something equals 6, remember there's two possible versions of it. So there's a positive version and a negative version. So you're just going to rewrite this without the absolute value, the x minus 4 part. But then you're going to set one of them equal to 6, set the other one equal to -6. Because if this thing equals -6, it still has an absolute value of 6. All right, so go ahead and solve both of these on paper and see if you can find the solutions. Okay, so hopefully when you solve the one on the left here, you got 10. When you solve the one on the right, you get -2. Those are your solutions. And you can see these on a number line. They're both 6 spaces away from 4 on a number line. And that's what absolute value means, is how far away is it on a number line. All right, for B, as soon as you're given this problem, if it says the absolute value of something equals a negative number, you can say, no, it cannot, because you can never, wait, that was tiny little text, look at that. Because you can never have an absolute value be negative. Therefore, this one has no solution. There's no number for x that makes this true because you can never have an absolute value that's negative. All right, so those are the two cases, one where you can solve for two things, one where there's no solution. It can't be done. All right, so the next one, how would you solve this one? What would your first step be when you're solving this? Okay, if you said your first step is to add 10 to each side, you're correct, because the first thing you want to do is get all the absolute value stuff by itself with nothing extra next to it. So here we'd add 10. So all we're left with here is 3x plus 9. The absolute value of that is 6. Okay, and then you're going to solve two different equations. One where 3x plus 9 equals 6, and one where 3x plus 9 equals -6. So those are the two equations you'd write out. And then you solve them. So on paper, solve them. Let's see what you get. All right, so hopefully you got -1 and -5. Those are the solutions. Yay! All right. Okay, now we're going to move into some special cases, I believe. Oh, first one is story problem. So here we have a cheerleading competition. The minimum length of a routine is 4 minutes. That's the shortest length. The maximum length is 5 minutes. Write an absolute value equation that represents the minimum and maximum lengths. There's a little trick to this one, which we're going to get to. So first, make sure you understand the problem. And then you're going to make a plan. Consider, this is the big trick to these. Consider the minimum and maximum lengths as solutions to an absolute value. Use the number line to find the halfway point. So anytime you're solving or writing an equation that has like a minimum max, find the halfway point. So what's the halfway point between 4 minutes and 5 minutes? Yeah, it's 4.5 minutes. So that's going to be our key. So we're going to say that x minus 4.5 minutes has to be 0.5. That's the distance from the halfway point to the max and the min. That would be our equation. Okay, and when you solve this equation, that gives you 4 and 5, but that was our original story. So sometimes you are taking a story, coming up with the equation. Sometimes you're taking the equation and answering the equation. All right, so now here we got inequality signs on both sides of the equal sign. When that happens, don't freak out. You're still going to do the same thing. So what you're going to do is rewrite them without the absolute value. One where this equals the positive version of this stuff on the right. Again, you're just replacing the absolute value here with parentheses. Or where it's the negative absolute value part over on the right. Okay, so notice here, this negative only goes with the absolute value part. The 2 is still 2. I'll let you reflect on that. Just pause and see if you notice why they went from this to this. Okay, so again, you rewrite them, one with the positive version, one with the negative version, but the negative only goes with the absolute value, not anything outside the absolute value. And then you solve distributive property here, and you solve and you get -6 for this one. You also have to solve this one. So you distribute that negative, then you distribute the 2, and then you solve it, and you find out for this case that x equals 0.8. So we have 2 different answers for this one, -6 and 0.8. So absolute value equations will have 2 answers, or in some cases, this one, I believe, is where we're going to have our first extraneous case. So you would solve this the same way as you did before. You will set 1 equal to 4x and 1 equal to -4x. And then you got to solve them, just like normal. There we go. So it seems like 6 and -2 are both answers to this. Now we're going to do what's called look for extraneous solutions. You should always do this with all of the problems you solve. Plug them in, see if they make sense. What we're going to do is we're going to plug 6 in here and see if it works. So when you plug 6 into the original equation, you get the absolute value of 24 equals 24. That's true. That works. So 6 is a solution because 6 works. Notice, though, when you plug in -2, which was our other answer here, you plug in -2, you get this. So is the absolute value of 8 equal to -8? Because -8 is what you get over here when you plug in -2. No. No absolute value is negative. Therefore, this answer, which is a solution to this equation, isn't a solution to the original equation. So the solution is only this one, x equals 6. That works. -2 does not work. It's rejected. It's called an extraneous solution. So it's super important to plug in your answers back into the original one and find out if they actually work or not. Okay? The ones that don't work are called extraneous. And then we got our last example here. So to solve this, again, you would set it up the same way. Set one up where x plus 5 equals x plus 11, and then do the other one where it's x plus 5 equals negative, and then in parentheses, x plus 11. So when you solve this, you end up getting x equals -8. When you solve this one, you get this equation where you get 0 equals 6. And that doesn't make sense. Okay, so again, what happened was when you solve the negative case, it works and you get x equals -8. Okay, but when you solve the positive case where x plus 5 equals x plus 11, That doesn't work. Okay, this is like when you solve the linear ones and you get the no solution. So in this case, there's no solution. But there's only no solution to the second equation, to the positive version of it. Okay, there is a solution when you, so x equals -8 is a solution. So this one has a solution, but when you solve the second version, the second one doesn't work. It has no solution. So overall, the solution is only x equals -8. Okay, that may have been confusing. Anyway, as you're working through more of these problems, if you have questions, make sure to ask questions. It might help to rewatch this video or use the dynamic classroom in Big Ideas. All right, good luck. I'll see you next time. Arr!